Hello everyone. So in this lecture series, we'll be solving the numerical problems from the book, The Problems in General Physics. Okay, from Problem in General Physics, E Irodov, and the publishers as Mir Publishers, Moscow. Okay, students. So in this section, we will solve the numerical problems from E Irodov. As you know, that this book is having the good level of questions, okay, and also which can clear your concepts. So from this we will solve the numerical problems, that also from the part 1 students. Okay, I repeated, that also from part 1 of physical fundamentals of mechanics and the section number 1.3, that is laws of conservation of energy, momentum and angular momentum. Okay, so we'll be solving the problems from laws of conservation of energy, momentum and angular momentum. Okay, 1.3 section. So students, let me share the screen for you. First of all, let me see the question number. Okay, 1.3 session. The page number is 30. It said that. Suppose this is, let me mark the page number. It's 38. Okay, students. So the question is this. Okay, this is from here it starts. This is section number 1.3. As you can see on your screen, laws of conservation of energy, momentum and angular momentum. Work and power of the force. These are the theory points. You can see it if you want, but I'll be directly going to solve the problems. So this is the problem number 1.118. Okay, students. A particle has shifted along some trajectory in the plane xy from point 1, whose radius vector is 1 plus 2j, to the point 2 with the radius vector r2 is 2I minus 3j. During that time, the particle experienced the action of certain forces, one of which being F equal to 3I plus 4j. Find the work performed by the force where R1, R2 and F are given in SI units. Okay, students. So let me copy the question for you. And share the whiteboard. Okay, students, share the whiteboard. Here is the whiteboard I have shared for you. So the question number was, I think, 1.118. And this was the question. Okay. So this is the question for you, students. Here we go. Let us start solving the question. Let me erase the, okay, students. So you need not to see this part, this I have, it miscopied here. So let us start solving it. Okay. So this is the question, and the question says that a particle has shifted along some trajectory in the plane xy, okay, from point 1, whose radius vector r1 is 1 plus 2j, students, whose radius vector r1 is 1 plus 2j. Okay, let me confirm by sharing the screen again, students. We can share if you want again. It was this only. Yeah, 1 plus 2j. Yeah, that's right, students. So let me share it again, students. Whiteboard for you. Okay. So students, R1 vector is 1 plus I plus 2j. Okay. And R2 vector is 2I minus 3j. Okay. So the particle is in the xy plane, students. The particle is in the xy plane. This is x and this is y plane. Okay. Xy axis. Okay. And the particle just shifted from 1 plus 2j. Let us mark that. Suppose this point is I plus 2j. Okay. So this is, let me mark it as I plus 2j vector. Okay. So this vector is from here to here. Okay. This is I plus 2j, students. Okay. So, and the second vector is R2 vector, which is 2I minus 3j. 2I minus 3j. Minus stands for, students, negative I axis. 2i is positive and minus 3j. Somewhat maybe it can set somewhat here, students. Okay. So let me mark this vector. So this vector is, students, this. Okay. So this is, students, 2i minus 3j vector. Okay. This is R1 vector, students, and this is R1 vector, students, as I marked with orange color. So let me mark it with again with orange color. And this is, students, R2 vector. This is R2 vector. Okay. So the question says that the particle followed some trajectory in the xy plane from point 1 whose radius vector is 1 plus 2j. This is point 1. Okay. And 2.2 with radius vector 2i minus 3j. This is point 2. So from 1.1 to point 2, so let me mark a vector here, vector difference from point 1 to point 2, is R2 minus R1. Or what we can say, R1 minus R2? No, from this vector to this vector. Okay, students? Okay. So from here, what do we get? So we will write it R2 minus R1. Okay, that is from R1 to R2. Okay, so let me write it here. R2 vector minus R1 vector, that is a vector from point 1 to point 2. Okay, so this will be R2 minus R1 will be equals to 2i minus 3j, 2i cap minus 3j cap. You can write minus of I cap plus 2j cap. Okay, students, 2i minus 3j minus I cap plus 2j cap, it will be equals to I cap. Okay, and this will be equals to minus 3 minus 2 minus 5j cap, students. Okay, so this comes the vector difference, you can say. Okay, this is a vector difference. We want to contain more. During that time, the particle experiences the action of force, one of which being 3i 4j. Okay, one of which being 3i 4j. So find the work performed by the force. So we know that work is F dot dr. Okay, so dr, we know that dr is basically dx I cap plus dy j cap plus dz k cap. Okay, so let me take a new slide here. So this will be F dot dr is equals to, what was at the back side? Vector was 3i plus 4j. Okay, 3i plus 4j. So this will be equals to 3i plus 4j. Okay, and dr is dx I cap plus dy j cap plus dz k cap. Okay, since one trick is that since we know that force is constant. Okay, students, since we know that force is constant. Okay, so we can say that F dot, if we get the magnitude of this differential vector, we can have a dot product with it. Okay, so we know that the vector difference is this. So taking its magnitude, we'll get equals to root somewhat of, no, taking this vector as with it. Okay, minus 5j. So 3i plus 4j I minus 5j, which is equals to 4, which is equals to, sorry, which is equals to 3 minus 20, which is minus 17. Okay, so the work done here is basically the work done here is basically minus 17 joules, students. Okay, which comes as minus 17 joule, which is the required answer. And we can solve by this also. So for this, what we need is, let me take a new slide again. So we know that F dot dr. Okay, we will solve it with coordinates method. So the force was 3i plus 4j. So the force was 3I plus 4j, and the dr vector, okay, dr vector, we know that it is dot product of dx I cap plus dy j cap plus dz k cap. So if we do a dot product with it, it will come out to be 3dx plus 4dy plus 0dz. This will cancel out 3dx plus 4dy. Okay. Now what we need to do is integrate. Okay. So this will come out to be work done. So how within the limits? So limits we can see from the question. The points are C. The initial point is first point. Okay. It has the coordinates x coordinate as equals to 1, y coordinate equals to 2. For the second point, x coordinate is 2, y coordinate is minus 3. Okay. So when using the limits of x, we will say that when using the limits of x, I'm doing it with blue pen. When using the limits of x, okay, don't say this, okay. When using the limits of x, we will do within the limits x equals to 1 to x equals to 2. And when for y dy, we will use the limits y equals to 2 from y equals to 2, y tends to 2 to y is minus 3. Okay, students. So let us put the limits. So x1, y2, and y2, y minus 3. So come here, x1 from 1 to 2. Let me not use this circle here. From x1 to 2, from y2 to minus 3. So let's see what comes answer. It's 3x and 2 1 plus 4y and 2 minus 3. So the answer comes out to be 3 plus 4, and this is minus 3 minus 2. 3 plus 4 minus 3 minus 2 is minus 5, so it comes out to be minus 20. So work done equals to 3 minus 20, which is equals to minus 17 joule. This is the required answer, students. This is the required answer. So we can match it. See here. So look here, we can see that this is minus 17 joule. Okay. And here also it was minus 17 joule. So from two methods we solve this question, and the answer is minus 17 joule. The two methods were this. First, we consider the force is constant. So just putting the force and dot product of the differential vector, which we have found out here at first only. This one is was a differential vector. Okay, students. So this is a differential vector. By using this differential vector, okay, and then using it in the trick of the question, which is this. This is a trick of the question, students. Answer came out to be minus 17 joule. Then again, as we have initiated this method before the trick method, so for this method we will put the limits. Limits is from the point, as I've told you, these were the points x1, y2, y minus 3. So putting these points in the limits, that is 1, 2, 2, minus 3. So this is the limits I put it, and the answer came minus 17 joule. Okay, students, the answer is minus 17 joule. Okay, so let's move further. So let's move further. Let me share the screen for you. Okay, students. So let me share the screen for you. So this is the screen. Question number 1.119. It says that a locomotive of mass m starts moving so that its velocity varies according to the law of velocity equals to a root s, where a is a constant and s is the distance covered. Find the total performed work, total work performed by all the forces which are acting on the locomotive during the first t seconds after the beginning. Okay, students, first t seconds after the beginning. So let me copy this question on the whiteboard for you. So I have copied this question. Let me copy this on the whiteboard for you. Yeah. So this I have copied the question on the whiteboard. Let's use the whiteboard here. New page for you students, and this here. Okay. So this is our question. Let me use different ink. Let me use different ink. So, okay, now it's fine. So this is our question here. Yes. Students, one thing to note down here is that this is here. We mark it here. This is not R. This is actually root sign. Okay. This is A root S. Let me do it again. This is A root S. Okay, students. Okay, let's start solving the question here, students. Let us start solving the question. Okay, students. So, solution is this, that you know that locomotive of mass m starts moving so that its velocity varies according to the law v is equals to a root s. So let me write the equation v equals to a root s, where a is constant and s is distance. Okay. So we know that v is equals to ds by dt. We know that it's derivative of distance. If we consider it as magnitude, that is speed. Okay, because as distance is used here. Okay, so we will use like this a root s. Okay, so sending dt in that side is RHS a root s dt. ds is s minus half. Okay, and a dt. Okay, students, that is integrating it from the limits within the limits 0 to t time t, as initial time is from reference, that is origin, t equals to 0, and at time distance covered is 0, and that s be capital S, small s if you can write if you want. Okay, so from here we will get that if we'll integrate this, we'll get s minus half plus 1 divided by minus half plus 1. You know that this is integration formula, everyone. I hope that everyone must know this. So within the limits 0 to s, and this is a t 0 to t. Okay, students. So this comes out to be 80, and this is s plus half raised to power, and this comes out to be half at the bottom, at the base. Okay. So this is root s. Okay, students. This is root s, and this is 80 by 2. This is root s, and this is 80 by 2. Okay, so now we square it, it will become s equals to a square t square by 4. This is s. Okay, students, let me take a new page for you. S was s equals to a square t square by 4. Okay, students, this came out to be s. Okay, so now s is this. Okay, now in the question it is asked that find the total work done, work performed by all the forces which are acting on the locomotive during the first t seconds after the beginning of motion. After the beginning of motion, okay, total work. So students, it's so easy. You know that we know that we know that students, we know that work done. We know that work done by all the forces. Okay, students, we know that work done by all the forces is equals to change in kinetic energy, students. We know that work done by all the forces equals to change in kinetic energy. And by this, I mean that change in kinetic energy is equals to final kinetic energy minus initial. I'm using F as subscript and initial. Okay. So from here we'll get the answer, which is asked that here we were asked that to find work done. Okay, total work done. So from here we will get this. So here is this. Yes, kinetic energy initial and kinetic energy final minus kinetic energy initial. Okay, is final. So we know that we get the distance is equals to a square t square 4. Okay, we need to find the v. Okay, we got the v as from C, students. In the equation, this first equation, we can mark it as first equation. In this, v is equals to a root s. Okay, so v was a root s. Okay, so if we square it, v square, it will come out to be a square s. And if we put this s here, students, so it will come out to be v square is equals to a square multiplied by a square t square by 4, which is equals to a4 t square by 4. Okay. Okay, students, and we know that, and students, we know that kinetic energy equals to half mv square, and for the final we will use m v final square. Okay, and for initial we will use half into m v initial square. We know that velocity initial was 0, as if you put in this formula only, if you put s equals to 0, which corresponds to t equals to 0, okay, then v will come out to be 0. Okay, so this will cancel 0, because it will tend to 0, it is equals to 0, students. So work done equals to half m v final is equals to, from this we'll put v final, if we will make it equal to v final, okay, at particular time t, which corresponds to the distance s traveled in any particular time t. Okay, so this is equals to half mv square, which is equals to a4 t square upon 4, and t is here basically, the corresponding time to the velocity vf and distance traveled s. Okay, so this is our required answer, that is done by all the forces. Work done by all the forces equals to m constant a raised to power 4 t square by 8. So students, this is our required answer. Okay, so now we got the answer, that the answer is work done by all the forces is equals to ma4 t square, students. Okay, as it was asked in the question that find as it was asked in the question that find the total work done performed by all the forces, which we got as ma4 a raised to power 4 t square by 8. Okay, so students, let us move to the next question. For this next question is, students, so okay, let me share the screen for you again, book screen for you again, students. So this is our book screen, and this is problem. So now is the problem number 1.120, students. Okay, now the problem number is 1.120. Okay, students, so let me read the problem for you. The numerical problem says that students, the kinetic energy of a particle moving along a circle of radius r depends on the distance covered s, as capital T is equals to a square. Okay, this is the variation of kinetic energy and distances. Okay, where a is constant, find the force acting on the particle as a function of s. Okay, so we need to find the force acting on the particle. Okay, so let me copy this question for you, students. Let me copy this question for you on the whiteboard, so everyone can see. So okay, students, so let me share the screen whiteboard for you. So this is the whiteboard, and okay, students, this is the question here. So this is the question on your screen, students. Okay, students, so let us solve. Let me take different ink and let me start solving the question here. Oh no. Okay, students. Yeah. So solution. Okay, it's given that the kinetic energy of a particle, kinetic energy. Okay, students, it's given here that a kinetic energy of a particle moving along a circle, of radius r depends on distance covered s, as t equal to a square. Okay, so t signifies, students, kinetic T signifies, students, T signifies as kinetic energy. Okay, students, T signifies as kinetic energy. As given that T is equals to constant A S, which is distance, square. Okay, so T is equals to A multiplied by distance raised to power 2, or distance square. Now we are asked the force acting on the particle as a function of S. Okay, since the particle is moving in a circle, let me draw a diagram for you, students. So let us suppose this is a track of the particle, and say suppose that particle is here. Okay, students, suppose that particle is here, and let us suppose that the radius of the particle is, suppose that radius of the particle is from the center. This is the center, suppose. Yeah, so this is the radius of the particle, students, which is equals to given as capital R. Okay, so now it's given that the kinetic energy of particle. So if the particle is moving with, say, with some speed here, or having the tangential velocity here, students, as v. Okay, so that will be a tangential force, that will be due to some tangential force of it. Okay, so this is T is kinetic energy, so we will write it as half mv square. Okay, as square. Okay, so this is kinetic energy. We know that work done is equals to force dot ds. Okay, for tangential cases, and which is equals to change in kinetic energy. Okay, so if we'll do dw by ds, students, and also we can do dk by ds, which will be equals to force, and in for circular motion case it will be equals to tangential force, students. Okay, students, so circular motion case it will, so students, this is dw by ds. Okay, dk by ds, which is kinetic energy differentiated with respect to distance of the curve. Okay, and this is equals to tangential force. Let me take a new page here. Okay, since students we are given as T is equals to, which is kinetic energy, is equals to as square. You can check it out. Okay, this is as square. So we know that we need to find dk by ds, which is equals to, according to the signs used, dt by ds equals to 2as. Okay, students, so this is equals to 2as. Okay, so this is equals to 2as. Okay, students, so from here we get this, which is equals to dw by ds is equals to 2as. Okay, which is equals to tangential force. Yeah, this is equals to tangential force, students. Okay, and we know that kinetic energy is also written as half mv square. Okay, which is equals to as this. If you use this here, it's same here. This is equals to kinetic energy only, students. So it's equals to half mv square equals to, as per the question, it is equals to as square, students. As per the question, students, it's equals to as square. So mv square 2a s square, it will be equals to 2a square. We know that, some students, centripetal force or the radial force, centripetal force or the radial force is equals to, in a circular case, it's equals to half mv square upon radius. Sorry, mv square upon radius. So dividing both sides by capital R, it will be equals to 2as square by capital R. Okay, students. So it will be equals to 2as square by capital R. Okay. So from here, let me take a new page for you. From here, we get two forces. That is centripetal, that is tangential force, which came out to be 2as, because here, you know, students, dw by ds equals to dk by ds equals to tangential force, and this was kinetic energy. So we differentiated it, and we got 2as. Okay. So tangential force is equals to 2as. Tangential force equals to 2as, students. Okay. And from here we get a radial force or centripetal force equals to, students, centripetal force is equals to 2a square by r. 2as square by r. So centripetal force, students, equals to 2as square by r. Okay, students. So this is 2a square by r. Okay, and we need to find the net force here. Okay, so in the question, students, in the question it is said from, it is asked by us, it is asked that find the force acting on the particle as a function of s. So total force, by force it means total force. So total force, since we know that in a circular case, we know that it will draw a diagram for you. Suppose that this is circular case. Okay, so suppose this is radius, this was a point. Suppose that this was a point for the particle. It was having some like this. Let me, okay, it was having some like this kind of tangential force. A radial force will be in this direction. So the angle between tangential force or the radial force or centripetal force is equals to, students, it's 90 degree. Okay, or pi by 2. Okay, students. So the net force will be equals to F radial, or you can say that FC whole square plus F tangential whole square, which will be equals to root of 2as whole square plus 2as square upon r whole square. Okay, so this will come out to be, students, F net is equals to under the root of 2as whole square, which is equals to 2a square s square plus 2a square. Okay, 2 square a square s4 upon r square. Okay, students. So if you take the common terms will be 2a and s, and under the root of 1 plus 1 plus s, okay, square upon r square. So students, this is a net force which is a function of s. Okay, net force is a function of s, and this was only asked in the question. Okay, so this in the question it is asked this only, that find the force acting on the particle as a function of s, and we got this. We got the force acting on the particle as a function of s. So this is force, total force acting on the particle in circular motion, and this is a function of s here and s square. Okay, students. So this is the answer. So let's move further to the next question, students. So let me share the screen for you for the next question, students. So this is a screen, students, for the next question. No, students, this is yeah. So students, this is the next question. A body of mass m was slowly hauled up the hill by a forceps, which at each point was directed along a tangent to the trajectory. Find the work performed by this force if the height of the hill is h, the length of the base is L, and the coefficient of friction is K. Okay, students. So let me solve this question for you. Okay. Okay, students, this we will solve in the next video. Okay, students. So see you further, and if you have any doubts, just comment me in the comment box or mail me on my email ID. I will write my email ID in the description link. Okay. So thank you everyone. So bye. See you later.